We're going to see the remaining two lessons of the same module. Is my screen visible?
Yes,
Is my
Krish.
screen?
Yes, yes.
All right. So as we know, this is a troubleshooting class. So logs file also play very critical roles whenever we're going to find any issues in our labs. Guys, if you find someone in the waiting room, please allow admission. Logging and logs file. So we're going to see what is the importance of log files, what kind of information we can find in the logs file, where is the location of these log files. So you can see most vCenter server logs files are on the vCenter appliance. So it is a Photon Linux operating system. This appliance contains. On the top of that, we have vCenter server applications, and it's a database, PostgreSQL database. So several services belongs to our vCenter servers, and that all services relevant to logs file we can find under this location. So once you access this location, if you make a cookie connection or right click on a VM open console, you can access this location, and as you can see, all the files belongs to your vCenter server appliance. Can you tell me which is the most or main process of the vCenter server who forward your all requests from the vCenter server to ESXi host?
कौन करता है?
Which process? Huh?
OPXD.
VPXD.
Yes.
So then relevant file, log files also can find. This is the main process of your vCenter server who receive your input and forward your input to the ESXi host. And inside the ESXi host, which services receive your all the commands, all the instructions from vCenter server? VPXA. Can you find that here? No, because that is running in the ESXi host, right? So vCenter server components have subdirectory. For example, VPXD SECS subdirectory contains vCenter services logs. Logs created during the first boot process that got written in this directory. And here we can find during the boot process vCenter server encounter big problems. So for that purpose, we can see this logs file. Some of logs file we're going to see. As I explained, vpxd.log. That belongs to vpxd process. vpxd services also maintain its logs file, and the name of vpxd.log file is the main log file of the vCenter server. Most vCenter server action we can track through this vpxd log, and this is also you can find under the same location. Several other useful logs can be found in the var log VMware directories. You can see some of the logs file of the vCenter server. I hope each of you aware about PostgreSQL. That is what the database of the vCenter server where it keeps all the configurations, all the data. Content library, another feature of vCenter server where we can keep our templates, ISO file. You have an option at the content library level. You can make a subscribe the libraries. You can publish the library. You can create a local library. Synchronization take place continuously between your subscriber and your published content libraries. Content libraries related issue if you face, so we need to look into these problems. PostgreSQL database. The SSO maintains its own database separately. That is called VMDIR. So that relevant logs file we can find here. vSphere services lifecycle managers, vSphere client services, whether working or not. If not, you are not able to connect to vCenter server by using the vSphere client. And how you can upgrade your existing vSphere environment, how you can manage your vSphere lifecycle management. So we have built-in feature service like lifecycle management, relevant logs file we can find there, VMware authentication framework daemons, VMware service control engines, agent, and VMware appliance management services. So any of these services related problem whenever we find. So it means what exactly happened, what kind of problem the services facing not coming up. We really need to look in these files, logs files. vpxd.log. Whatever actions triggered by the vpxd to vpxa. So vpxa we have available this agent services running in all the ESXi hosts. And vpxd can directly communicate with vpxa. So vpxa forwards all the request actions to vpxa, and then vpxa forward to whom? All the actions triggered by the vpxd forwarded to vpxa, then vpxa forwarded to whom?
Kernel hypervisor.
So if you access ESXi directly then by using host client, who receiving the instruction?
Host DC.
Listen, host D vpxa. If you are accessing directly your ESXi, it is the host D receiving all your instruction. But instruction coming from the vCenter server, so it is the vpxa. So here we have vpxd, and vpxa forward it's all the information host D, and host D finally submit that to the hypervisor ESXi. So all the instruction we send to the particular specific ESXi from the vCenter server, whether it is receiving or not, whatever action you triggered from the vCenter server, we can track that from the vpxd.log, and whether these successfully received by the vpxa or not, so that we can separately track in the vpxa.log files. So vpxd.log also you can find in this location in the vCenter server virtual appliance, and when you're going to read it, you can use the cat or vi editor command lines. So you can read all the text, all the logs file, you can find a huge text. To find relevant information, you can make a search inside. Let's say I'm facing a problem regarding vMotion, so I can just find in this big file a vMotion's word. Or since what date and time you're facing the problem, when you scroll it down, you're going to directly access the date and time stamps. I know very well this problem coming for last 2 days. I grab the logs file of last 2 days from date and time. Easily you can start searching. vpxd.log file ESXi hosts heartbeats informations. As we know, vCenter to ESXi continuously sharing the heartbeat master to all your subordinate hosts, subordinate all subordinate to master hosts. There is a heartbeat concept. So that's why sometimes you can see heartbeat continuously 4 packets missed. So it is showing host is disconnected. So whether the vCenter server receiving heartbeats of the ESXi host or not, that information also we can track in the vpxt.log. Task detail communicated to the vpxa on the management host. So that also we can see inside the ESXi host. So whether you, let's say, trigger the one action powering on a specific VM. So this instruction received by that ESXi host or not, how becomes to know. We need to see the vpxa.log file. If you see the ESXi host under this var log ls, you can see there's a huge logs file. Generally, most of the time we use for troubleshooting the logs file. One is your direct host d.log. Remember these important files whenever you're going to fix the problem in your lab environment even or in your production environment. Mostly used file to investigate our existing issue. Host d.log, whether it is receiving or whatever action it triggering in the ESXi host, receiving from the directly host client or from the vpxa, and networking, storage related all information we can track from very important. And from today's topic, we are going to cover networking. So whenever we face any networking related problem, you must need to look into the VM kernel.log, very important files. VM kernel.log, most of the networking related things, storage related things, we can track from the VM kernel.log. So vpxa.log, and also we have also VM summary, VM warning, that is also belongs to indirectly from these VM kernel files. If you have HA related some issues, what is the name of HA agent?
FDM agent.
FDM agent. Where is this FDM file?
FDM log.
So here we have fdm.log file, which we're going to see in the HADRS module. So you can see so many files we have. What is this file? If you're aware about vSphere with Tanzu, so you can see additional one whips get placed inside the ESXi, that is SphereLab. And SphereLab also has its own log file, SphereLab.log file. So many files we have, authentications, boot, cluster agent. So, but today's our main focus must be for the host d.log, vpxa.log, and VM kernel.log. Because students, we have a module to discuss and cover, that is network. So networking related all issues must need to look into this VM kernel.log, and you can find that inside the ESXi. So here you can see hostd.log, host management services. So syslog.log management service initialization, watchdog, schedule task, DCUI, information who use DCUI at what date and time. VM kernel.log, for VM kernel logs including device discovery, storage, networking service, networking devices, drivers, events, virtual machine startups. That all information we can see in this VM kernel.log. And VMK warning, VMK summary. Summary of warning, alerts, log message, extracted from the VM kernel logs. Summary of the ESXi for startup shutdown, that all information, an hourly heartbeat with uptime, number of virtual machine running, that all information we can find in this VM summary.log file. So when you try to open the VM kernel.log files, you can use the cat or you can use the VI editor to open these logs file and start reading, investigating, and try to find the clue. So initializing and loading the drivers into kernel modules when you power on the ESXi host, so that information, all the drivers kernel module gets successfully loaded. Mounting the file system connected successfully to the storage, and services startup, that all its services get started successfully. That all information we can find in this kernel.log file. Starting a script initial complete, host boot status after ESXi host is up running. This file contains entries for the storage, networking, device event, which are useful for troubleshooting storage and networking. So storage related issue, networking related issue, you must need to look into this VM kernel.log file. ESXi host uptime, availability, VMK summary.log. Even you can see directly. Yesterday we have one command ESXtop. ESXtop also we easily comes to know the uptime of the ESXi host, but similar kind of much more detailed information you can find in the VMK summary.log file. Host boot status changes when you rebooted, powered on your ESXi host, hourly heartbeat informations, receiving every virtual machine send its heartbeat every second to the ESXi host. That's why it gives you VM level protection also. With not getting heartbeat from the specific virtual machine, automatically attempt powered on the virtual machine. And that's benefits we have in the protected virtual environment when you configure high availability cluster. And we have also VOVD.log file contains observation about VM kernel, which includes the following events. Events sent to the host D, enabling services, configuration, any changes in the ESXi firewall rating, any changes occur, so that we can track in this VOVD file. Observations file. Synchronizing of the system clock, storage of connectivity status. You can see the NNA ID of one of the LUNs which we are using as a VMFS data store. So if you have two VMFS data store, VMFS 1, VMFS2. One is local, another one coming from SAN. How you can identify? Going to deploy the virtual machine in the SAN-based VMFS data store. How you can identify? You have two VMFS data store. Which one coming from the SAN? which is your local, or you can identify. Is there specific identity for the SAN-based storage, for the local storage? What is that?
Sorry?
Anyone? I have a VM to deploy in one of the VMFS data store. One is coming from the SAN, another one from the local disk. How you can identify? Which one is the local? Which one coming from the SAN?
SAN one will be having the no ID. The local one will not.
So SAN-based storage having this kind of NNID, some vendor also started as a T10. If any device start as T10 dot long string like this or NNA dot long string, it means this NNID based data store display name share to coming from SAN. But if it's showing local, so its name started NPX dot long string. NPX represent your local storage. So this is also we can see which particular path right now you're using, or the path is available or path is down. So you can see by using this path cannot access the shared to name the data store because it is a down. VMHBA 65 channel 0, target 0, under the target 0 we have 1 3 and that path is a down. So by using this path you are not able to access this, but might you have another path still available, but it's showing right now as per given. This path is a down. Network link connectivity status. So that all information also we can observe in this log. VM NIC represent what? Either you can use the term uplink, you can use the term physical NIC, or you can use the VM NIC. They all representing physical LAN card in the ESXi host. Managing ESXi host operations, host d.log. The host agent responsible for managing ESXi host operations such as VM creation management, vSphere vMotion, ESXi host configurations, for all the things, because we know very well it is the host view receiving instruction from both ends. From the host client, from the SSH, from the vSphere, in VPXA, it is the host, the process who receiving all the instruction from the vCenter. So it manages some file, d.log file that also you can open and try to read whether it performed successfully the received task or not. Creation, completion of task, VM, state transitions, basically when you power on, change the power state, host boot status. These are much more information you can find in a host.log file. When you power on the VM, the host.log file shows the task to power on VMs created. Eventually the task completed and you see a success status. You can see task is created. That all information given in the host.log file. So trigger the power on action. Many information you can see whether this task gets successfully created. 7474 and status is success. Host D was not detected. Okay, Host D perform all the actions, whatever instruction it's receiving from the VPXA or from the host client, as I said. But if host D itself not get some problem, then who going to track that events? Because host D performing many action and it also writing that all action in the logs file, but it is itself get problem. So we have alternate one another service whose job is to monitor and watch continuously your host D process. Host D process get suddenly problem, so that event we can track at what time your host D process get a problem, and that every 5 minutes host D process checks whether host D is running and documents its finding in this. So host D at what time stop responding. To monitor that thing, you must examine this log. Host D dropped out, right? And when you start looking into it, so somewhere you can find like host D was not detected in date and time. VPXA.log. In all ESXi we have these services. This actually the vCenter server agent running in all ESXi hosts. So VPXA cannot talk to directly with host D agent. vCenter server places its own agent in all the ESXi hosts. When you add ESXi or register ESXi in a vCenter server, so VPXA sends its all instruction commands to the VPXA, and which is running inside the ESXi host, and it manages its own logs file. So sometimes we can trigger the commands not get successfully triggered as action. So we want to see whether VPXA receiving it, the commands from the vCenter server or not. Do we have communication properly between the VPXD and VPXA? Times of last log rotation, time of last service start, the VPXA process, build version, that information you can find here. Host status and configuration changes sent to the vCenter server. So you trigger the action from the vCenter power on the VPX. So that instruction received by the VPXA pass it to the host D, host D now submit to the hypervisor trigger the action, and it also receiving the feedback. VM gets successfully powered on, yes. So host D to VPXA, VPXA to VPXA, and we can track, okay, so now VM status is up. It means it gets successfully triggered this action, power on the VM, power off the VM. Information about the vCenter server agent, VPXA.log file. So quick states data sent to the vCenter servers, whatever it is receiving from the host D. Virtual machines task information, whether you trigger the action power on, power off, delete, read, it gets successfully done in the ESXi host or not. VPXA send feedback back to the VPXD process running in the vCenter server. We can see as admin the action gets successfully done or not. And VM level changes, VM level action you want to track, at what time someone add more RAM, more CPU, more disk, or at what time someone reboot the virtual machine, remove the virtual hardware, add the virtual hardware. That all action we can track from the VMware.log file. Where you can find this file? Where we can find this VMware.log file?
Same, slash.
What? Slash what?
//log.
Slash what?
I think
No,
it,
no.
no, it's no, it's in a data store, right? In a VM folder. There you can find the store is.
Yes. This is belongs to your VM, and every virtual machine having its own VMware.log file that you can find within this virtual machine's own directory, where you have other flat.vm, and vram, .vmx. In the same folder directory, you can find VMware.log file. So if you want to see virtual machines level, what exactly happened, virtual hardware changes, add or remove, VM migration events, VMware tool status, powered event, power on, power off, and all action you can track in a VMware.log. And also in the same directory, you can see some archived file like VMware 001.log, VMware 002, 003, 004. So historical information you want to retrieve for this particular virtual machine, you can see archived file. Latest front information you want to track, you must need to see the VMware.log. So whenever you reboot your virtual machine, existing VMware.log file get archived, renamed like VMware 003.log, and when you power on, again it will get the VMware.log. So current information at the VM level, we can observe from the VMware.log. Historical information we can get through this archived file, VMware 001, 001, like that. Using vSphere logs files, although log file contain vast amount of information, use a small percentage of that information for troubleshooting. Yes, you can see a lot of information as a text information, so very difficult to scrutinize and find the relevant information. So we do not need to look all the entries, specific information we need to see, and that we can scrutinize with the date and time. Or we can make a search to the specific phrases, keywords, determining which logs file to consult for any given problem. That depends what kind of problem you are going to look into, which file relevant or file we need to look and find. And even you know the file, I need to find hardware related changes at particular VM level, so that VMware.log file you need to open. And once you open, might be some specific keyword you need to find, some phrases you need to find, some messages you need to find. Use the objects name such as a VM name, ESXi host name, network uplink name to improve your searches. What specific information you want to see. Find the date and time. Since what time this problem coming, you do not need to look the logs from the beginning to end. So current information always you can find in the last. Any log file, it start writing from the top to down. Sometimes you just need to see last 10 lines, 10 to 15, 10 to 20 lines, only last you need to check to the latest information. And this is also, yesterday we have seen DCUI, Direct Console, User Interface, last alternative, you lost management connection to the ESXi host. So this is the DCUI where we have view system log, and you just need to use these. Press 1 to see syslog, press 2 to see the VM kernel .log file. So 6 which we have, we can use to see the host DVP, XA, VOVD directly on the DCUI console, only to go to specific location. So small labs we have, here you're going to see some files, logs files related to authentication. Also, you're going to see one another log file which wants to know at what time user get login and what is the user's IP address from where he attempted to access the ESXi. So that information also we can track in the logs file. And then we have VMware Skyline overview. What is a VMware Skyline? What is the purpose of VMware Skyline? So VMware Skylines helps to reduce the total support times. So VMware Skyline is a proactive support technology that provides predictive analysis and proactive recommendation to help you avoid the problems. VMware Skyline provides benefits. Issue avoidance, because it continuously tracks your all the configurations. As per you configure the HA cluster, DRS or other configuration as per the best practice of VMware, as per the recommendation of VMware. Yes, no problem. No, start giving you recommendation. So shorten the time to resolve issue avoidance, because if you start looking the recommendation and start following the recommendation, so it means what? You are avoiding upcoming problems in futures. Shorten time to resolution, environment specific, data driven analytics, accelerate problem resolution. So your data automatically get uploaded to the VMware teams, but that depends. For that you need premium support. If you have premium support, it means what? You have a dedicated VMware teams who continuously work in your data center based uploaded data. Your information from your data center get automatically uploaded to the VMwares, where we have a dedicated VMware teams who continuously watching, monitoring your all the data center based configuration data. So it comes with a basic production and premium support. If you want dedicated teams should be involved, you must need to buy the premium support, or you can take a basic, but basic just very small information only recommendation I can see. There is no dedicated teams, and same thing like production support more function than the basic. But the premium support, it means I will get all the feature functions of this VMware Skyline, and I also get one dedicated VMware support teams. Some person they locate to investigate continuously without approaching you. They in advance start working whatever data received from your data centers. The VMware Skyline family includes Skyline's Health, Skyline Advisor. The Skyline Advisor comes with a premium support. Skyline Health, all VMware customers, it is available. And key capabilities, it can monitor vSphere, vSAN by using the vSphere clients. Minimum you need vSphere 6.7 in order to use this Skyline family product. And you must be need premium support or production support if you want to get these features. Skyline Advisor, some more products also get involved that also get in these additional product, whether it is a realized operation managers or your other product like NSX, also becomes the part of your this VMware Skyline family. Skyline Health provides findings for your vSphere and vSAN. vSphere environment As we know, vCenter, OLSXi, network, data store, HADRS, all configurations of data. It's going to observe, and based upon observation analytics, it's going to give you some recommendation. And same thing for the vSense, if you are using vSense. So you can see within the vCenter server, we have this Skyline's Health to check which information we want to monitor. So you do not need separate appliance, separate console. You must join the Customer Experience Improvement Program CEIP. The vCenter server instance must have internet connectivity. And if you are using premium or production support, then you need to deploy some additional appliance. So Skyline Advisor, Skyline Collector works together, provide proactive supports. Skyline Collector is a standalone virtual appliance. You need to deploy, integrate with the vCenter server. It is responsible to collect all the diagnostic data from different technology, whatever technology you are using in your data center. And Skyline Advisor gives the web-based portal, has its own dashboard. Whatever information it collects, it's going to perform the analysis and produce the result. In the graphical form, we can see all the corrective finding recommendations on demand live. And sometimes VMware support teams also access this Skyline Advisor web-based. It is a web-based portal to retrieve the information about your data centers. How VMware Skyline works? So it has its own components, Skyline collectors that you must need to deploy in the form of virtual appliance, and this we need to configure so it can receive the data from many endpoints. Endpoint could be vCenter, could be ESXi, whatever endpoint configures. From that, going to collect the data. And on the collected data, perform its own analysis, and based upon analysis, now going to gives you recommendation. So this is its portal. You can see Skyline Advisors, from where we can see, even if you configure it, you do not need to configure separately centralized log server. It automatically sends all the logs from your endpoints to this Skyline Advisor. Based upon the data it received, based upon analysis it on the received data it made, it will give you findings, some recommendations, multiple tabs we have. We can use this all to see all the information. Finding recommendations we can find. That depends how many endpoints we connected to it. And this is a logs information. When using Skyline Log Assist within the same dashboard, you do not have to upload your logs manually. Support logs bundles can be automatically uploaded to the VMware technical support. And feature-wise difference, you can see the basic only gives you 3, and if you have production, you can see some more features. And if you want to use all features, you want to have a dedicated VMware technical support teams for your data center continuously, we must need to use premium support. And it's not like your data centers all informations going to the warehouse of the VMware. So all the information not it going to send, only the configurations information it going to send from your data center to VMware's warehouse, where it is going to collect all the information and analyzes that all information. And all the informations we do not expose to the internet. It is in an encrypted way we send from your data center to VMware warehouse. Data is warehoused in a secure backend system in the United States and is managed by the VMware, and access to your data is restricted to permit users only. Information is limited to data such as host name. Data that is known to identify an individual person is not collected. So this is also, we have features. So now we can proceed for the lab number 4, where we're going to see some logs file. And in that log file, we're going to see some authentications information, or the user connected to vCenter server from which device, what is the IP address of that device, where I can see that information in the log file. So everyone must need to complete lab number 4, maximum 15 minutes. You can continue to complete the lab 4, and let me know in the chat box once you've done the lab number 4. If you face any problem, let me know also. And then we're going to see the next interesting module, network. So everyone must need to proceed for the lab number 4. And how many we have percent today? 14. One is absent. Let me take a screenshot as your attendance. Is it working? So first of all, we need to know about the network. So how you can set up a network? I'm talking about physical network. So you have switches, number of ports, where you can connect your PC. So if you want to make that all the PCs should talk to each other, we need to make a connection between the switch. So this is a one simple physical network topology. PC1, PC2, PC3 can talk to each other. Very first time, PC1 want to communicate with PC2. How the communications take place? What information PC1 needs to know about PC2?
MAC ID.
Yes. IP address, suppose you logged in, PC1, hitting IP address, let's say 10.0.0.1, 10.0.0.2, layer 2, a network we have among all three machines. The very first time you log in the PC1, pinging 10.0.0.2, so it means you're providing the destination IP. Source IP, its own IP, you know very well. Still, it needs to know the destination MAC address. So for that, what the process they use? How they learn the MAC address of destination PC? Is always broadcast one to all, where we have whenever any layer 2 frame gets generated. So what information we have? Source IP, destination IP, source MAC, destination MAC, and data payload. So this is information we carry in the Right, layer 2 crane. Source IP, you know very well, 10.0.0.1, destination you providing configuring 10.0.0.2. Source MAC, let's say this is a A, this is a B, this is a C. A. Destination MAC doesn't know, put the FFF field, represent the broadcast. So once it sends this packet to the switch immediately put this entry, MAC number A, available at my port number 01, 01, 2, 3, 4, 5. And similarly, destination MAC is a broadcast sent to all the enabled ports. So since we have only 2 ports enabled, so it forward to. If you have suppose one more machine in the same switch, it's sent to the same PC3 also, PC4 also, and the same broadcast also sent to this PC3 because it is a single broadcast domain. PC3 access it, process it, discard it, it is not for it. But PC2 when processed, it knows that this is for me. So it process it and give the response packet. So on the response packet, this MAC address of the PC2 learned by a MAC B available 012 port number 3. So this is how they manage the MAC table. And then ongoing communication is the one-to-one, send to one to particular ports. And similarly, PC1, PC3 first need to generate the R process in order to know the MAC address, then after they start the communications. So this way, layer 2 communications take place. So now we want virtual network. So then what happened? You have virtual environment by using your hypervisors. And now if you have hypervisor, it means we have then virtual environment. So when you prepare few hypervisor, so this is suppose your hypervisor. So it is now also layer 2 but software based switch. And these all becomes now your virtual machine. VM1, VM2. And this is your ESXi host. And this is your uplink VM-NIC 0 or uplink 0 in physical LAN card from where you can plug the cable, and in another hand this is suppose your physical switch. So how VM1, VM2 can talk to each other in the similar way VM1, VM2 can talk to PC3. So VM1 send its packet to the virtual switch forward to the physical switch, and physical switch forward the traffic to the PC3, and PC3 in the similar way give the response back. So now tell me, how many MAC address we can find in this physical switch? In the MAC table, if you see the MAC table of this physical switch, how many MACs you can find here? In this physical switch, how many MAC address you can find?
Physical switch.
Probably one.
Which one is that?
PC3.
Don't forget, if it manages only PC3 MAC address, any it want to go for the MAC A, MAC B. How this physical switch can forward the traffic to the MAC A, MAC B. So this physical switch needs to maintain all the MAC address in its MAC table. A, B, C. A, B, C. Plus, don't forget, VMK0, VMK1. So VMK0, VMK1, VMK2, VMK, and these all also virtual LAN card. Each VM kernel port group itself a virtual NIC. So every VNIC must need unique MAC, unique IP. Unique MAC get automatically generated. That is the ESXi responsibility. We are responsible to make sure they contain unique IP address 20001, let's say 30001. So traffic generated by 10001, 10002, 20001, 30001 has to use this single LAN card to send the traffic out to the physical switch and receive the traffic in from the physical switch to virtual switch to physical switch. So physical switch needs to maintain all the MACs. VMK0 MACs, VMK1 MAC, PC1 MAC, PC2 MAC, as well as PC3 MAC. So 1, 2, 3, 4, 5. 5 MAC addresses. It needs to maintain its MAC table. That's why it comes to know if any traffic you want to go for the MAC B, in which port it is available forward that. So against this port, it needs to register A, B, suppose G, A. So these 4 MAC addresses registered against this port. Any traffic want to go for the G MAC address, A MAC address, B MAC address, A MAC address, forward to port number this one. Now, how we can maintain the redundancy in a hypervisor? So you have a single point of failure. If this happens, you cannot survive. You lost all the connectivity from virtual to physical network. So to maintain connectivity, you need minimum 2 adapter connect. And in a physical also, you have to make redundant network. Might be any time one switch get failed, so you still can go to the another Uplink, another switch in order to go to another hypervisor or in order to go to the internet. And within ESXi host, you can have more than one virtual switch also. Minimum 2 adapters. So whenever you have new vSwitch, we do not have concept like we cannot share the existing physical LAN card between the switch. Whenever you create a new LAN card, a new virtual switch, you must need to attach a dedicated new LAN card. The existing LAN card you cannot attach to the new switch. So if you have more than one switch, make sure every switch having its own LAN card dedicated uplink. So in each virtual switch, you can have your multiple virtual machines port group. Please mute yourself. Get in my back. So you can see here, if we have more than one virtual machine port group, let's say the name is broadcast. If you want, you can mark VLAN. VLAN 10. VLAN, let's say 20. So some virtual machine connected to VLAN 10, some virtual machine connected to VLAN 20. So now, whenever more than one VLAN exists in the same switch, so it means what? There is a one mandatory requirement at the physical switch level. What is that? Because if you don't configure special thing in the physical switch get confused. Sometimes the packet I received from this link showing VLAN tag 10, but same link I received another packet which showing the VLAN tag 20. Get confused. Why the packet showing VLAN 10, VLAN 20, VLAN 30? Even I am receiving packet the same link, we're going to by default discard over the packet. If you have more than one VLANs, you are going to handle its traffic on a single port. That port must be configured as a yes. So now it's going to handle all the traffic. You can see now number of MAC addresses get increased as you increase the number of virtual machine, number of VM kernel ports. So in the physical switch, the number of MAC addresses also going to increase. Day by day, number of virtual machines get increased, and it's not only one hypervisor. You have several hypervisors attached to the same physical switch. So it means what? Might be after 6 months, 1 year, you need to replace small capacity switch with high capacity based switch. Because the whole MAC we need to manage. And this problem solved by the NSX technology. If you implement NSX, so as per given scenario, 1, 2, 3, 4, 5, 6, 7, 8. 8 MACs we need to maintain in the physical switch, but once you implement NSX, you only expose VM kernel port to MAC address. You do not expose virtual machines, MAC addresses in the physical network device. So physical network device only can see VM kernel MAC address, not the virtual machines MAC address. If you're using the NSX technology, it means with the NSX technology, you can use even small capacity based physical switch. That's no problem. And we do not have concept like physical switch to physical switch, you can make a direct connectivity. Similar way, do not support the concept like a virtual switch to virtual switch direct connectivity. Do not support. Because of this, we have advantage. Because if you have two different redundant paths between the physical switch, there is another challenge comes. What is that? If you have physical switch 1, physical switch 2 with a redundant network between, you have challenge that is called what? Loop problem. Any computers generate a broadcast frame get forward to all the ports. Once it sent the port and this the broadcast frame in this port received, and then it forward to this because of broadcast packet. So packet get loop, and it is in layer 2 infinite loops going to occupy all the bandwidth. That's why to solve this problem in a physical switch we have a STP, spanning tree protocol. And STP option you cannot find in the ESXi in the vCenter server because loop never occur in a virtual environment. We do not have concept like a physical network which we do not support switch to switch direct connectivity. Now tell me, the VM1 want to communicate with this VM10. VM1, this one, want to communicate with VM10. How the communications take place? VM1 attached in this virtual switch and VM10 attached in this another switch. How the communications take place? For a while, don't consider VLAN, otherwise you need to use either same VLAN. So virtual VM send its packet to the virtual switch forwarded packet to the physical switch, and physical switch to the virtual switch, and then it goes to VM. So internally, the virtual switch to virtual switch we cannot connect. Spanning tree protocol, keep one of the paths in a block state. Avoid them. Not physically, logically. Physically, both are well connected, but logically one path not allowed to use for the switches. So switches can use only one path to avoid the loop problem. We solve the loop problem by using STP. What STP gives you another challenge. If you have, let's say, 100 Mbps, 100 Mbps or more, We cannot use 200 Mbps, we can use only 100 Mbps within the switch. So to avoid the loop, to use all the available bandwidth, we have a link aggregation or LCP or ether channel, it is also known as. By using ether channel, we logically make this as a single tunnel. No loop, and we can use all 200 Mbps bandwidth. When you really lost one physical path, you still have 100 Mbps bandwidth. Okay. So whenever you get any confusion regarding your virtual network, you must need to concentrate on the physical network. It's 99% same. Only 1% difference we have seen that there is no virtual switch to virtual switch direct connectivity. So another discussion, if you have two different VLAN, two or more VLAN, VLAN 10, VLAN 20, so every VLAN represents one separate network. VLAN 10, VLAN 20, so it means we definitely talking about two different networks. So between two different networks, if you want to establish communication, what is your requirement?
We have to define the routing.
Somewhere you must need to use the routing. So there are different ways to use routing in a virtual environment. You can use physical router also, and whatever interfaces you have here, those you need to use as a gateway inside the virtual machine. Or we can deploy one virtual machine with a multiple VNIC, and one NIC be attached here, another VNIC be attached in the another VLAN enabled protocol. We deploy a virtual machine with a two VNIC, one in VLAN 10, another one we attached in VLAN 20, and inside this virtual machine you can configure routing.
This one point I'm having.
Yes.
We can use layer 3 switch except layer 2. Then we can avoid the router part. Like we can done the routing part on our switch, layer 3 switch also.
Yes. This, if you want, you can use the layer 3 switches. And between VLAN communication happen through this layer 3 switches. Yes. This works as a switching as well as a router. Yes, sometimes we can use a leaf switch as a layer 3 switch. So we want to handle inter-VLAN routing or communication at this leaf level switch. So yes, in that case we can use the layer 3 switch. Sorry, second.
Actually, I told you like it can simplify our network architecture.
Yes, correct. Yes, we can do that. But generally, again, even you are using here layer 3 switches, still the problem is here pinning problem, which means if you have source virtual machine and destination virtual machine on the same ESXi, they cannot talk within ESXi because of they are using different network. They must need to go out, then perform the routing in a physical network device, then come in. So that's why these kind of challenges still we have. These kind of still challenges we fixed through the NSX. NSX is going to provide logical router, software-based router within your ESXi hypervisor. So multiple VLAN you can connect to logical router, and this is sitting inside the hypervisor as a kernel services, and it avoid to use any kind of physical routers and not use any kind of here pinning problems. But NSX beyond the scope of this course, just I am giving you some idea. NSX solve what kind of problems? NSX gives you logical router, logical switch, and logical firewall. So within ESXi host, what types of network traffic we have within ESXi host? You have different types of network traffic. Minimum 2 adapter, high capacity LAN card we need to use, and both connected to different level switch to avoid the single point of failure. So here you could have vMotion's traffic, you could have storage traffic, you could have your management traffic, and you can have your virtual machines traffic. So these multiple types of traffic exist inside your ESXi. To access the IP-based storage, you must need minimum one or more VM kernel. Because if I have a storage, iSCSI storage is also IP-based storage. I want to access it is using 20 network. So how I can provide 20 network based on virtual network interface in the ESXi. So for that purpose, you need to create these VM kernel portal virtual NIC. So while you're creating this virtual NIC, you must need to assign the same subnet, whatever subnet your storage is using. 20 subnet your iSCSI storage NFS using, so you can provide 20.0.0.1, 0.0.2. 2 for the redundancy purpose, for more network input purpose. By default in the ESXi host, we get the standard switch. But if you want more advanced features, centralized management for the networking, we prefer to use the vSphere distributed switch. So when you use the term vSphere distributed switch, what does it mean? What are its different features supported, which we cannot get from the standard switch? And in your production environment, we generally prefer to use the distributed switch instead of standard switch.
Set line arrangement, private VLAN table.
So
Inbound
we're going
traffic
to
setting,
see
private VLAN.
the architecture of distributed switch also. So as I told you, because here we have a troubleshooting post this one, so the theory part we have less. We expect you should know all the concept of how the standard switch works, how the distributed switch works. From the networking perspective, there is no difference between the standard and distributed switch. Both gives you the layer 2 network connectivity. But yes, feature-wise, when you see, yes, we have some more feature when it comes to the distributed switch. First main advantage we have, switch using one port from the virtual switch, and whenever you create VM kernel port group like VMK0, VMK1, so it means these also itself VLAN, which directly you are creating to access a specific services from the ESXi host, carry the host management traffic. You could have several VM kernel port groups. We can recognize this through command like VMK0, VMK1. In one hand, we have these virtual LAN cards. 1, 2, 3, 4, 5. All 5 virtual LAN cards going to occupy one port on the virtual switch. And we have VMNIC, VMNIC 0, VMNIC 1, they represent physical LAN card. So when you attach the physical LAN card, they also going to occupy one port on the same switch. If you're using everything for every kind of traffic, if you are using only single virtual switch, so from the same virtual switch, you are going to attach all the VNIC or all the physical. And then under the NIC timing, that depends how you're going to consume both of the NIC. What you want to configure active or you want to configure active standby. And these are the common logs file. VM's level problem we have, go to this vmware.log, host d.log. Host have done successfully all its assigned job by the vCenter server. And then network related any issues, any configuration change done by the ESXi host, storage related any configuration, that all we can track from this. And this is of observability. So same you can see host d.log, vm kernel.log, vod.log. This most of the time this model you must need to look into this vm kernel.log. VOVD logs file reports on many events including uplinks, physical LAN cards information you want to track. Must need to look into this file. It will show to you VNIC 0 is up, VNIC 1 is up, uplink redundancy restored on the distributed switch. This kind of information we can retrieve from this log file. So now we're talking about standard switch IO chain work number. Because when the traffic generated by the virtual machine or by the hypervisor at the VMJ0 level, network drivers which do not comes automatically. VMware tools must be installed, and virtual machines default network doesn't give you VMXNet. Instead, it gives you VLANs, E1000. Okay, then that depends whether you have just operating system 32-bit or 64-bit. So always we manually while deploying the VM on drop down list we need to select VMX. And selecting VMXNet not enough inside operating system, you must need to install VMX. So traffic generated by the virtual machine send it to the VNIC. VNIC is nothing, it is just one virtual driver receiving all the traffic going to either VLAN, VLAN 10, VLAN 100. Then at the switch level, at the port group level, if you remember, you have these sub policy: back address change, accept or reject, post, transmit, accept or reject, and promiscuous, accept or reject. Until you do not have special region, keep all the three options: reject, reject, reject for the security purpose. So by the way, what is a promiscuous mode? To configure promiscuous mode. Accept, what does it mean? When you configure promiscuous mode, reject, what does it mean? These feature in a vSphere ICM class, you have detailed discussion, traffic shaping. Because by default, there is no restriction. How much bandwidth we have available, the virtual machine can consume all the bandwidths. If you do not put a limit, the problem is might be DRS trigger vMotion for 3 virtual machines. Your own, or you can say 90% bandwidth consumed by the vMotion feature. vMotion action will get triggered by the DRF automatically. 90% available bandwidth consumed by the vMotions. No bandwidth left for the enough bandwidth are remaining free for the management traffic, storage traffic, virtual machines traffic. So you must need to use the traffic shaping, put some limit. App should not use more than 2 Gbps. vMotion should not use more than 1 Gbps. Storage should not use more than 2 Gbps, like that. And MAC address host promiscuous. Promiscuous mode, if you configure except as a vSphere administrator requirement, suddenly one of the applications will start flooding a lot of traffic in the network. Why? What kind of traffic? Or what's going on with these UBS virtual machine? I want to track. This is belongs to customer 1. Customer Y want to share his credential. You have no access to login inside the VM, customer VMs. But I want to track what's going on between A and B. What you can do, you just plug your own virtual machine, C. You have full access because it is belongs to you. You deployed it, you have full access as admin. And then plug this in the same folder where you have AB, that as a vSphere admin you can do, and enable this promiscuous mode. Yes, it means what? Whatever traffic A and B generating at the hypervisor level, make a duplicate package. Original packet sent to the original destination, but the duplicate packet sent to this virtual machine. And inside the VM, you must install or run a network monitoring application like Wireshark, Tools, or any others. Analyze what kind of traffic they are generating, what's going on between A and B. For that small division, to solve this problem, you can enable promiscuous mode. Except once you get your own the result, again put it back to reject. Because you cannot keep it enabled all the day. 24/7, 65 days, it will take more burden on the ESXi, each and every traffic to duplicate. Unnecessary. Then reject. What does it mean if I configure MAC address, post MAC address reject?
You want to go to see the packets.
Code accept. You must need to know, otherwise how you can fix the problem. Each of these features you should have good understanding. So MAC address, it means I am a user who put the or who RDP, I am working from home. I'm accessing resource from my organization-based data center. And I'm an owner of this application server, so it means what? I can do whatever I want. When I access remotely, I want to steal the old data. I modify the MAC address. I want to bypass all the security. I know the security implemented based upon MAC address. My VM has a specific particular MAC address. How I can override all the existing security? Change the MAC address. So when you access this VM, you change the MAC address. It means you want to bypass all the security. But as a vSphere admin, we configure MAC or post once reject. Once you change MAC address, immediately ESXi comes to know someone changed the MAC address of your virtual machine. You immediately lost. The VM immediately lost its information. So until you do not get approval that this is the happen, this VM cannot communicate with rest of the other whole VM or physical machine. So that's why we configure this MAC address post reject, reject. No one allowed to change the MAC. If we try, we can only access this VM as admin. We know very well from the LAN card property, some operating system allowed you to change the MAC address. Whenever they try, we lost the change. So these all things at the port group level, at the switch level, it's the kernel, VM kernel, hypervisor going to check at that one. Then, finally, once the packet arrives in the virtual switch, still it needed to know what kind of, under the NICT you are using load balancing policy. MAC has, IP has, port ID. And based upon
अभी तो कनेक्ट हो रहा है
get generated by the virtual machine, traffic get generated at the VMs level, at the port group level, at the switch level. Make sure all the configuration is configured correctly. Whenever networking related any issue with this, generally in a physical environment, we often use the ping-up just to check from my device to the destination device we have a communication or not, just ping. Similarly, ESXi VM kernel port group you want to test vMotion VM kernel from source to destination. So instead of ping, we use the command vmkv. Interface, which interface? VMK0, VMK1, VMK2, VMK3, VMK1, okay, and IP address, which is destination. This way you can check from your VMK1 to destination VMK1, do you have
Yes,
notifications or not?
Commander.
Trace route also we can use if you want to see some your router dropping the packets. How many routers we have between source and destination. We can use the trace route. And see, these all things you're going to use when you're going to perform our labs. In this lookup, might be I'm not able to access the destination with FQDN, but if you try to access this IP address, a relevant IP address, it is allowed to communicate. So it means we have a problem only with DNS. And MT, if you want to see your IP is listening on particular port, or that particular port only, it is not able to listen, but normal communication like other ports are allowed, but only specific port, whether it is listening or not. So the destination IP listening on this port from your end or not, we need to do this. 8260 generally, what it represents.
इसका ये सर 902 और उसके लिए vMotion के लिए
iSCSI storage.
वो तो TCP भी है ना 902 905 भी है
944
So this is also
अरे
one
उसके
of the
लिए
verification. Make sure on the destination
443
the
web
target storage.
वेब का नहीं तो मैं इसका ESXi को कर रहा हूँ
6029.
905 नहीं
We can use
और
all
3-4 है 443 भी है
ESX
ESXi को
This is the command lines. Some commands you also must need to know. If some of the VM kernel port groups showing down, so first of all you can run the ESXi network NIC list. It will show to you the status of the VM kernel port group, and one of the VM kernel port group is showing down. So this is the command you must need to remember. ESXi network NIC up -n, then the name of the VM kernel port group, VM NIC 0, VM NIC 1, VM NIC 2. Display the RPN network discovery cache. Any system, whenever from your laptop, if you ping a new IP, first learn what is the IP of yahoo.com, google.com, ping it, and you can see relevant MAC address in your MAC cache. How many MAC it boosts and maintain in its cache that I can see. Display information about your distributed switch. How many distributed switch we have, it will show to you only. And you are going to assign particular IP addresses to the VMKG through the commands. ESX, ELA, network IP, interface IP, version 4. If it is a VMK1, VMK2, you can do that from the vSphere client. But if VMK0 down, you are not able to connect to it over the network. You need to access its ESX, ELI, local command line cell, and then we can use the command lines to change its IP. vSphere command packet capture. We can use this command packet capture -UW command is enhanced packet capture and analysis tools, and you can use instead of legacy TCP lines. So this command to troubleshoot dropped VMs disconnected uplinks. For example, you can run the command to help determine whether the packets are dropped on the ESX side host or in the external network, physical networks, where exactly the packets getting dropped, at the VM's Winnick level or uplink level. So how we can use this command, capture packet at the virtual machine's virtual switch port, where the port ID, which is virtual machine using, that is this one. So you're going to capture the packet. Virtual machine using VNIC, and this VNIC using one port from the virtual switch, and this is the port ID I received. Comes to know through the command line your VM using which port, and at this port you start capturing the packet. Who comes to know VM is able to send the packet at the port level, is receiving or sending successfully or not. And this is VM K0 level I want to capture the traffic. That is host management traffic. And this is I want to capture the traffic at the uplink level, physical length. Remember, VMNIC represent physical length. VMK0, VM kernel port group, is also virtual NIC. And this is VM's virtual NIC using which port in the virtual switch, and that port level I want to capture the traffic to know whether VM's receiving or sending by using this port traffic or not. So all three levels you can capture the traffic. Uplink level, VM's NIC level, or VM kernel port level. VMK0, VMK1, VMK2. And one more time. Okay, so this is where you want to capture the traffic. Physical LAN card level, or VNIC level, or you have VM kernel port level. Where exactly you want to capture the traffic. You can monitor traffic at many points in the host network stack by running the packet capture -UW command. Capture packets sent to the virtual switch from the virtual NIC. Passes a list of packets from the virtual switch port to the uplink. So virtual port to the uplink. How many packets it sent? Or capture packets sent to the uplink. At uplink level now, we have either been receiving or sending the packets or not. So these three levels we can capture the traffic. Network problem, what is given here? ESXi host connectivity issues. So network related any issues we have, we often use this thing. initial check from the ESXi shell, that is a local command line shell, ping system that is known to are accessible by the ESXi host. Any other virtual machine, any other IP which is available, which is out of this ESXi host, we just want to know whether our ESXi is responding over the network or not. Identify possible causes. You identify possible causes of the ESXi host network connectivity problem. If you know that your hardware is functioning correctly, take a top-down approach to troubleshooting, starting with ESXi host configurations. So what things you can check at the ESXi level? ESXi host network configuration is make sure correct, it's not incorrect, and your virtual machine using or connected to the right port group, and at the port group level you have a right to VLAN, and the speed and duplex, half duplex, full duplex, that accordingly the physical switch connected to the physical LAN card. So we need to map that also. The network link is down or the pin is not properly configured. That all options we can check at the hypervisor level. And everything is correct, then we finally need to see, do you have sufficient resources available? If not at the VM level, so might be at the VM level when you think it's not responding because of to handle all the packet it doesn't have sufficient CPU memory, or we might be recently added one LAN card. That LAN card is not supported by the hypervisor. Every kind or every vendor specific LAN card are not supported by any hardware for the ESXi, must be checked in the VMware hardware test online, which is available. Or network performance, are the physical LAN card level some packets dropping or not? Because dropping always must be 0. There is no value greater than 0 accepted. If it's showing the network dropping, it means it is not able to handle all the required incoming outgoing traffic. vSphere standard switch configuration. To determine cause of the ESXi host connectivity problems, verify that the ESXi host network is properly configured. So for that, we can use the commands, how many total number of standard switch we have. So generally starting from the 0, vSwitch 0, vSwitch 1, vSwitch 2, you can see 2 switch number of we have in this ESXi host when we run this command list. vSwitch 0, vSwitch 1. In a vSwitch 0, we have a virtual machine port group that is the default name VM network. But in a vSwitch 1, I have given the name production as 01. So this way we can see the list of number of virtual switches, how many we have, how many virtual machine port group we have, and you can see configured port, MTU size, and beacon whether we configured or not. And this is the distributed switch also. We can see, remember we cannot create it but by accessing ESXi host, but if it is already here, we can see detailed information we can set. You want to see the distributed switch, whether we have or not, it will show to you the name of the distributed switch and will give a lot of information. And here we can see the standard switch detail. Text field, duplex, network network uplinks, NIC status up or down. If suppose we are using unsupported LAN card, so let's say VMNIC 4 is unsupported. It will show to you VMNIC 023. Then here it will show to you the blank lines, no it. And directory starts showing VMNIC 56. It means that LAN card is not supported. And here relevant information you can see the class full MAC addresses and the most useful information link status must be on. And that you can see this command. So VM kernels also we can check if it is a down, we can make it up. Enable and configure MTU size to the commands line. Default size is 1500, but if you want to configure jumbo frame, it could be up to 9000 bytes. Get IP addresses assigned to the VM kernel commands. Set the IP address assigned to the VM kernel particular IP version code and configure VLAN. All these commands if you are doing a regular basis troubleshooting some tasks, you become very comfortable with these commands. And then we must need to check the nicknaming and failover option at the individual virtual machine port group level. Right click individual port group level, at its setting you can see naming and failover policy. And we have here IP has, MAC has, or you have explicit failover orders. If you are using distributed switch, then only you can find one additional load balancing algorithm, route based on physical link. So, in order to use, except this one, rest of the other all needs this one also. Minimum 2 uplink in the active list. Right now you have only one. So if you have one, you can use only this one. Use explicit failover order when you want to use one physical LAN card active, another physical LAN card. If you want, you can use here standby. So anytime these all are the unused LAN card, you can select any one of them, use up arrow, move them from unused to standby or from standby to active. So this arrow you can use to move up and down. So in order to use IP has, MAC has, originating virtual port, that is the default one. If you do not select anyone, this is the default algorithm works. Or the last one also, minimum 2 or more physical adapters in the active list. If you have 2 LAN cards, only one to use one active, one standby, you can use this one. Use explicit failover order, which uplink you want to use as active, which uplink you want to use standby. So that we can figure it out from the theming and failover option. Check whether the following ESXi network hardware issue exists. As I told you, if the unsupported hardware we are using, this would be the black one. The network adapter server hardware is not supported. Verify network hardware is listed in the VMware compatibility guide online. You can check before you're going to buy the physical LAN card for ESXi. The physical hardware is faulty, misconfigured. Run this command. So make sure the status showing up. And by using vSphere client, you can select individual ESXi host and go to the monitors And under the monitor, you can see we have the option overview advanced. For last 48 hours metrics only want to see, you can go to the overview. Or you want to see past 1 week history, past 1 month or 2 month or 1 week, 4 week history, you can use the advanced option. Or what's going on right now, you can select from drop down list the real time. The real time statistics. Show to you all LAN card, but you want to monitor specific LAN card. That also you can select from here. Which component you want to monitor, that you can pick up from your drop down list. Review of virtual machines connectivity. As we know, we have virtual machine. The virtual machine contain OS level firewall applications. So if you use up-down approach, you must need to investigate on that by communicating with applications owner. Make sure application listening using which port, that port is not blocked by the firewall. And then once you verify each and everything at this level, you're going to start your investigation at hypervisor level. VM using which port group, which VLAN, all the decrypting policy you must need to verify. And then uplink status. And temporarily you can ping a virtual machine or physical machine out of this ESXi box. Is it pingable on the other virtual machine from the other network or specific network has an issue, or all networks we have a problems not able to talk to that physical machine or virtual machine running in another hypervisor. So the VM running on another hypervisor must need to send its traffic to a physical network, then physical network to virtual switches, and then it goes to the virtual machine. So end to end, all you need to check. And that is what you need when you start doing the labs. So we have not taken the break, so I think we should take first break 15 to 20 minutes and come back.